Dr. Olivera Finn of the University of Pittsburgh School of Medicine is going to tell us a little bit about the immune system and immunology. She's the founding chair of the Department of Immunology at the University of Pittsburgh.
Thank you. Thank you very much. I've had a wonderful morning. It's a wonderful meeting. It's my first time here, and maybe I'll be invited again. I certainly would like to be. But on the way here yesterday on the plane, my seatmate, I think I sort of made him ask me because I was so excited that I was coming here. And so he said, "Oh, so are you visiting somebody?" I said, No, there's this wonderful conference, Imagine Solutions, and I'm going to be speaking at the conference. And he says, "Oh, so what are you going to talk about?" I said, "Well, I do cancer research." And immediately, like everybody else to whom I've ever said I do cancer research, my seatmate wanted to know, are we close to a cure? And then immediately, another question, what's been taking so long? Those are questions I get all the time, and I've been in this business a long time. But I always give the same answer. And it's a correct answer. It's a true answer. And the answer is, as you know, Otis said this in the introduction, that we've been since 1971, December 1971, when Nixon signed the National Cancer Act, talking about the war on cancer. And everybody knows this commitment as the war on cancer. And I tell everybody who asks me, you cannot win a war if you don't know your enemy. So for the last 40-plus years, this is what we've been doing. We've been trying to know, to understand, to get to know the details of what our enemy knows and how it fights us back. And fortified with that knowledge, which is an incredible knowledge that we've acquired over this since then, fortified with that knowledge, we have been able to develop new weapons for the battles that we are beginning to win. And with these weapons, we have learned how to use them specifically for every patient, because we have learned, as again was mentioned before, that every cancer is a separate enemy to us. And we have been very successful, and we should really celebrate that success. Last year, 2017, FDA approved 45 new anti-cancer drugs, every one of them better than what we have had up until now. Better, more effective, less toxic. And each one of those drugs is based on the scientific experiment that we have performed and gained the knowledge of what those drugs can do. So, as I said, the scientific discoveries have led us to this point where a lot of battles have been won. And also, as we've learned, we have been writing battle manuals. The manuals that can be sent to the trenches, to the doctors who take care of cancer patients. But all these years, there has been one battle manual written a long time ago, eons ago, that we didn't know it existed, and even if we suspected that it existed, we wouldn't have known how to read it without acquiring additional knowledge. And that is the battle manual written by our own defense system, our own body's defense army, our immune system. This is the defense system that on a daily basis surveys our bodies for intruders. And they can be viruses and bacteria from the outside, but they can also be intruders from inside, cells gone rogue. But for a long time, we didn't know that. We began to study the immune system. It was a very young science in the 70s, immunology. It was a very young science. We were just learning what the immune system can do. And we were learning a lot from transplant rejections. So the fact that we couldn't transplant organs easily from one person to another. And we assumed that the immune system was there to tell what is self versus non-self, meaning self, the cells that are generated by your own body, versus cells that can come from the outside, such as virus or bacterium. So as long as we thought about the immune system as self versus non-self discrimination system, we couldn't even imagine that it would then have anything to do with cancer, because no matter what, the cancer is a self, your own cell in your own body. But then the immune system is much smarter than we were. And we learned very quickly that this is not what is interesting to the immune system. What is interesting to the immune system is not what is self and what is foreign, but what is dangerous. And as Funmi pointed out, cancer is a genetic disease. Cancer is generated through a mutation. And the mutations change proteins in the cell. They change the way the cell makes products and secretes into its environment. It changes the metabolism of the cell. It changes how the cell can proliferate or not proliferate. It changes how the cell senses its neighbors, or as a cancer does not sense its neighbors and can overgrow an organ. And sooner or later, those mutations and those abnormal proteins and abnormal products that the cell makes make that cell look very foreign. It is not self anymore, and furthermore, it is obviously dangerous, and it signals this to the immune system to come and eliminate it. So, because of that, when we figured that out, it became possible then to say, well, let's then find out what can the immune system do on its own, and whether we can help it do it better in the cases where it fails and the cancer grows. So I belong to a generation of immunologists who decided in the late 70s, early 80s, to challenge this assumption that the immune system has nothing to do with cancer, and to simply ask the fact that a genetic disease like cancer is not growing in a dish, but it's growing in a host. How does a host respond to it? And as I said, how can we make that response better? So we started to look at differences between normal cells and cancer cells to identify molecules that would be of interest to the immune system. I trained at Stanford for my PhD with a cancer radiologist. He used radiology to oncology to treat cancer. I did my postdoc at the same institution with a cancer oncologist. But when I started my lab in 1982 at Duke University, I started a cancer immunology lab. The bias against the immune system having anything to do with cancer was so strong that I was told numerous times that this was going to be a career suicide. Well, I'm here. Obviously, it did not kill me. On the contrary, thank you. On the contrary, in 1989, we published the first ever discovered human tumor antigen that the immune system can use to recognize a tumor cell and eliminate a tumor cell. This was the first of many, hundreds of such molecules that were discovered over the period of the next decade. And so this was the decade of the tumor antigen discovery, and this was the decade for cancer immunologists to imagine solutions. And what we imagined was that these molecules can be then made into vaccines. And we could vaccinate cancer patients, boost the immune response, and which would lead to tumor rejection. So this is what we imagined. We imagine a cancer is diagnosed, the surgeon removes the cancer. We know that the cancer can recur because there are small metastases around the body that are not yet obvious, but in 3, 4, 5 years, they may regrow and come back. But we thought we would have a window of opportunity. We would vaccinate post-surgery and strengthen the immune response that would go and find these metastatic sites, eliminate the cancer because now it's a small tumor burden that it can handle, and that would basically be a cure. So the therapeutic cancer vaccines, we imagine, would be cost-effective, easy, non-toxic cure for cancer. We didn't come even close to that. It was a long road. In December 1993, I had just moved to the University of Pittsburgh. We actually started the first in the world, again, the first in the world, trial of a therapeutic cancer vaccine based on this abnormal self molecule. And we ran many trials like that, and most of my colleagues who were cancer immunologists at the time, with their own antigens, set up therapeutic cancer vaccine trials. There were antigens discovered for every human tumor, and there were vaccines developed for every human tumor. And the hopes were high. And the results were disappointing. We had some exceptional results that kept us going, but we didn't have any cures. We prolonged the disease, time to disease recurrence. We stabilized the disease. We made people feel better for a while, but we didn't have a cure. But this effort, which is an effort and that cost not only the scientists' time and money, but the patients' willingness and the families, et cetera, this effort did not go to waste, because from this effort, we got such an incredible insight into what the immune system in a patient with a cancer is like. And what we learned was that it was incredibly heavily immunosuppressed. We learned that one of the tricks that the cancer can play is to immunosuppress, to suppress every effector molecule, every effector cell of the immune system. And there are multiple ways it does that I don't have the time to tell you, but they're all incredibly interesting. So from these failed trials, this is what we learned. And that changed exactly everybody's thought about how we should then approach immunotherapy of cancer. We changed our focus from treating the cancer to treating the patient's immune system. Forget about the cancer. Let's help the immune system function better, and the immune system will then take care of cancer. So we developed such therapeutics, such drugs. We developed antibodies that blocked molecules on cancer cells that can suppress immune cells, and they can prevent them from killing the cancer. And these molecules, some of you know them, some of you have taken them as therapies. They're called CTLA-4, PD-1, PD-L1, and the antibodies, or the drugs that we are calling them now, that have been developed are called Yervoy, Opdivo, Keytruda. You even see commercials on television advertising these drugs. While they're difficult to pronounce and difficult to remember, one thing you should all remember, they are immunotherapy, and they are based on over 30, almost 40 years of very hard work of cancer immunologists. So give them the credit by not calling them drugs, but immunotherapeutics. The treatment with one of these antibodies, as you probably all know, is responsible for Jimmy Carter announcing that a couple of years ago that he was completely free of cancer, of melanoma that had metastasized to his brain and was going to kill him within months. But within months, he was making an announcement that he was cancer-free, completely cancer-free. He's 93. I just read that he was invited to give a commencement speech at Liberty University in May. He's in perfect shape. In addition to the antibodies, we developed cellular therapies. If the immune cells in the patient's body cannot work, let's take them out, away from the tumor. Let's expand them in tissue culture. We know how to do that. Let's engineer them to express receptors for one of those molecules that are different on tumors and versus normal cells. Let's infuse them back and have them find the tumors and eliminate them. And this works incredibly well. And the one example that I like to mention is Emily Whitehead. She was 7 years old. She had come to the University of Pennsylvania with a recurrent lymphoma that had stopped completely responding to all drugs and was going to kill her very quickly. She was 7 years old. In 2012, she received one infusion of her cells that were treated just the way I just described, and she was cured. She is now 12-year-old, healthy, wonderful young woman, young kid. So these two examples, by the way, they're wonderful examples, but they're not unique. Over 25% of people who are treated with the immunotherapy, with the antibodies, are cured. And over 60% of them respond with durable responses, with high quality of life and low toxicity. And in terms of the cellular therapy, it's even better. Over 90% of the people that get this therapy are cured. The only caveat is that we are only treating for now lymphomas, or liquid tumors, because they're more accessible. We haven't quite yet figured out how to make this therapy just as successful for solid tumors. But we have the playbook. We know what we're doing. And so sooner or later, and I think sooner because we have the knowledge, we will be able to have this 90% cure for solid cancers as well. In December 2013, the most prestigious scientific journal, Science, named cancer immunotherapy breakthrough of the year. This was quite amazing because usually it's a subatomic particle or some incredibly new chemical or some physical discovery. This was cancer immunotherapy as the breakthrough of the year. And I have to say that we cancer immunologists all took a bow, but a very humble bow, because we knew that we were not done, that the work is not done, but it's possible to celebrate successes and still move on and do more. And now for the very last and the shortest part of my talk, I am going to ask you to imagine something else with me, another solution. I have 3 grandchildren, 15, 10, and 6. And they use the word awesome all the time, awesome. Everything's awesome. But what I like, and I use it too because of them, but what I also like is Sometimes they go, it's like, it is so awesome. It's mind-blowing. So I'd like you to imagine with me a solution. I want you to imagine the world where not a single person or single family ever gets a shocking diagnosis of cancer, and not a single patient ever has to suffer the fact that maybe they cannot afford potentially curable therapy. We imagine the world without smallpox. We have it. We imagine the world without polio in Pittsburgh. In Pittsburgh, we imagine the world without polio. We have it. We can imagine the world without cervical cancer because we have the HPV vaccine, and if we make it broadly used and applicable, we will not have cervical cancer. And we can imagine the world without liver cancer because we have hepatitis B vaccine, that if we don't get infected with hepatitis, we will not have 20% of people perhaps developing liver cancer. We can imagine that. But most of our cancers are not virally caused. So we have to imagine the world also where there will be no melanoma, no colon cancer, no breast cancer, etc. And we can do that. Not only can we imagine this, but I am actually doing this. In 2008, we opened, again, the very first clinical trial of a prophylactic cancer vaccine based on the same type of molecule that we were using for therapeutic vaccines that wasn't working, because the patient was sick and suppressed, and chemotherapy and radiation they were getting were suppressing the immune system even more. But if we change the setting, and if we instead vaccinate people at risk for cancer, and reduce that risk and prevent the cancer from ever happening, then we have solved the cancer problem. So we started with people who, upon colonoscopy, are diagnosed with a large adenoma. It is not cancer, but it is a very close relative to cancer, and if you don't take it out, it will become colon cancer. And people who have those adenomas removed, 48% of them recur within 1 to 3 years, and if they miss it on colonoscopy, the next time it's going to be colon cancer. We vaccinate them, we induce a very high immune response, higher than we could ever get in cancer patients, and we induce very good immune memory. So now, if the polyp starts to grow, the immune system is ready. It'll come, it'll destroy it. And we have an efficacy trial going on, observation. We've done all the patients. We just started the trial in lung cancer prevention. This is not even a premalignant state. We have current and former smokers. We want to know who can respond better, the current smoker or the former smoker, because the risk is still there. And we are trying to get the immune system boosted, revved up, so that if a lung cancer starts to grow, that gets eliminated right away. And we are putting on the books a trial. All these trials are sponsored by the National Cancer Institute. And we are putting on the books a trial to prevent pancreatic cancer. 500,000 people were diagnosed with pancreatic cysts last year in the United States. Each one of them is at risk, but we don't know who is going to get it and who will not get it. Instead of removing the pancreas and making these people diabetics as a prevention of pancreatic cancer, we are trying to vaccinate these people and reduce their risk for cancer by healing the cysts and removing the risk for cancer. So the road will be long, but we are opening the door for other people who have other antigens and other vaccines, and they can do the same and choose their setting and high risk, and eventually, if it's safe and it's effective, we can move it even earlier. We can do a familial risk and vaccinate children when they can really respond and protect them, lifetime protection against cancer. The road will be long, and at my age of 68, I may have to rely on the next generation of tumor immunologists to come to the finish line, to actually win this long war on cancer. But this actually is one solution to the world's cancer problem that I can easily imagine. Poof. Thank you very much for your attention.